deterministic core meets the probabilistic LLM brain, unleashing the Chaos Playbook Engine.
What we're looking at here is something pretty surprising. It's about just how fragile AI agents can be, especially when they're operating in a real business environment. Turns out, even small system errors can cause their entire workflow to just completely fail. We've got 3 key takeaways on this. First, enterprise AI agents are extremely fragile. I mean, think about this. Even a moderate 20% failure rate in their APIs, the interfaces that let software systems talk to each other, that's enough to act as a catastrophic trigger for the whole system. That 20% API failure doesn't just cause a small disruption. Nope, it triggers a massive 70% collapse in the agent's overall workflow. The bottom line is simple. Without new architectural designs built to handle chaos, AI agents just aren't going to survive in the real world. All right, there are 3 essential takeaways here. First, the architecture is pretty unique. It's a hybrid model that separates the thinking from the doing. You've got a probabilistic brain powered by Gemini 2.5 that diagnoses the error. Then, a deterministic body of hardened code actually executes the fix. And it's this division that guarantees both speed and stability. Second, we saw this thing put to the test. When they hit it with a huge traffic surge, causing a common 429 error, the standard agent just crashed. But the Playbook agent? It caught the exception, found a proven recovery plan, and executed a jittered retry, which is a smart way to reconnect without overwhelming the service. And finally, the performance data is just incredible. The engine delivered a 60 percentage point jump in reliability during peak chaos, hitting a 98% success rate.
So what we're looking at here is this really important roadmap, the Hoja de Ruta. It lays out the whole evolution from a simple testing setup to a completely autonomous self-repair platform. First up, we start with what they're calling prompt science. The big idea is to stop treating prompt engineering like some kind of art and, turn it into an exact science. They're using this automated engine that just A/B tests different system prompts, making sure all the results are rock solid and scientifically repeatable. Second, resilience is now treated like managed software artifacts, all organized in a central playbook. And this is where it gets really interesting. They've introduced the agent judge. You can think of it as an observer agent that's always watching for failures. If it spots a problem, it automatically writes the fix right back into that playbook, instantly closing the loop. And finally, we get to universal infrastructure resilience. This is where they start applying the chaos proxy pattern to how agents talk to each other internally. The key tool is the chaos engine. What's so brilliant about it is that it can inject these real-time resilience tests directly into the infrastructure, all without ever having to touch the underlying agent code itself. So this whole strategy just fundamentally shifts resilience from being an add-on feature to being a core part of the infrastructure itself.